Hi everyone. In this video I'm going to look at differentiating the natural log function. To start off with, I want to do the actual proof of why the derivative works out the way that it does. It's a really nice one to prove. So we're going to start off with this equation here, okay, y equals log e of ax plus b, and I want to see what happens to the derivative of this thing. So I'm going to start off actually rearranging the equation to get x by itself. So first things first, do e to the power of on both sides. So e to the power of y equals ax plus b. And I want to get x by itself, so I'm just going to minus b. So e to the y minus b equals ax. And now I'm going to divide both sides by a. So that leaves x equals 1 on a times e to the y minus b. Now, I can actually differentiate this here in a fairly easy way. So I've got x in terms of y, so that means that I'm going to get dx dy, which you might notice isn't what we're really after. We're after dy dx, but that's okay. We're going to use this to actually get it. So when I do the derivative of this, well, we've just got some constant, because a and b are both just going to be constants here. Okay, so that one on a can stay at the front. And then just differentiate whatever's in here. So e to the y just stays as e to the y, and the b is going to just disappear. Righto. Now the thing is that we know from the very start that e to the y is equal to ax plus b. So what I'm going to do is sub in e to the y equals ax plus b. So that means that dy dx is equal to 1 on a multiplied by ax plus b. And we should be able to expand that to get dy dx equals, whoops, I've started writing dy dx instead of dx dy. Just go and fix that up. So dx dy was equal to this, and dx dy is equal to ax plus b over a. Now the nice thing here is that to get dy dx we can actually just flip this over, but I'm going to flip that over. I'll also flip this other side of the equation over. So dy dx is just equal to a over ax plus b. And this, basically, the reason I've done this is to show the link between these things. So the ax plus b, you might remember, was what we had inside the log function right at the start. And a, given that this is the differentiation topic, we can see a is just the derivative of whatever is there. So we can actually generalize this. You can show this with like any equation whatsoever, but I'll say that d dx of log e of f of x is always going to be f dash x over f of x. Okay, so the derivative of the log function is always the derivative of the inner function divided by the inner function itself. And that's actually really nice, because when we do something like d dx of log e of x, then the derivative of that is just going to be the derivative of this here, which is just 1 over the thing here itself, which is x. Anyway, that was all I wanted to go over on this particular video, but these two rules here I would say are very important with differentiating log function. Anyway, leave it there, and I'll see you next time.